Okay, Clark here with Killer Sudoku. I'm again on dailykillersudoku.com and I'm looking at puzzle 211. And the story behind this is my mother and I have been able to spend a bit of time together, which has been very nice. She likes to do Sudoku, and I've showed her Daily Killer Sudoku several times because I think the interface is nice, and the puzzles are right there on your phone if you want them, and it really makes for a nice solving experience. She likes to kind of have the paper with her, which is fine. So she said, "Let me try one of those." So we dug out an easy one. It was the second difficulty one puzzle, so it's puzzle 211. And one of the things as we were solving, I noticed that there were a lot of these places where the shape of the cages interacted with one and often more rows, columns, or boxes to give us a free cage cell value. And so I think all of us, we want to be better solvers. And for my mom, she had not really thought a lot about the interaction of the cages with the rows, columns, and boxes, and multiple rows, multiple cages, multiple rows, multiple columns, and multiple boxes. So this I thought was fun. So I showed it to her as I was solving. Look at this, look at this, look at this. And I thought, yeah, maybe this would make a good video. So anyways, hopefully it's helpful. I'm trying not to use the cages or use them as sparingly as possible to see how many values I can come up with just using these cage and row, column, box interactions. So here goes. I hope you enjoy it. So I'm not even going to look at some of these typical starting spots like the 1-3 or the what's another one here? Well, there's not a lot of them. 21, that gives you a few candidates. But what I wanted to do is start right here in the middle and attack this beast, this 29 cage. So my mom said, "Well, how do you see these?" And I said, "Well, what I try and do, you'll notice that in Killer Sudoku, a cage that contains multiple cells has this little inner dotted line that goes inside the cells that are part of that cage. So what I try to look for is I try to look for long lines. There's a big long line of on this side, especially on the 19 side, not so much on the other side, a big long line. And I don't know, maybe soft focus your eyes, but that line also continues all the way down here. Whoops, all the way down there. And so basically what we have is we have this area where all of these cells that exist in numbered cages and have values, they all can be selected, and it's so much easier in a solver like this online at Daily Killer Sudoku. I think it would be really a pretty serious math problem if you're doing it on paper. But we know that 4 columns sum to 180. And because we only have one cell that's not captured in this 180 total, we know that it is an 8. 172 is the highlighted cells, and this one cell of this 29 cage is not. So it is an 8. Gotta turn on number lock. It is an 8. And another thing about this puzzle is it is symmetric. You can see that this shape and this shape are the same across this cell here. So it's sort of the origin of the puzzle, if you will. Row 5, column 5 is the center of the puzzle. And if you took a snapshot of this and then spun it, you'd find that, whoa, those shapes are exactly the same. And now you'd have a 21 upside down here and a 28 upside down here, but they would be the same shape. What that means is that if you can do something kind of cool over here, like we just did, by filling in essentially 4 columns with only one cell sticking out, you can do the same thing over here. You can fill in all of these columns, columns 6, 7, and 8, and we find that total is 171. And so that makes this cell a 9. So we haven't really even looked at, cage values or, what combinations are limited by what. We've just been looking at the shape of the puzzle. Now it keeps going. It's actually really cool again. If you notice, there's this line that this line that goes along the top of these cells, and it continues over here. So if you can highlight all of these cells, you get 4 rows, which should add up to 180. And so these 2 cells, which are left out of that sum, need to sum up to 12 to get 180. Since we know there's a 9 there, 12 minus 9 is 3. So this is a 3. And we can do the same thing up here. So here we go. We have 4 more rows highlighted. 180 minus 165, that's 15. 15 minus 8 is 7. All right. So we've got almost all of the cells. Now we could calculate if we want, but it's going to be more fun if we notice that these 2 cages and these 2 cages are all in the same row, but exclude this one cell. So these 2 and those 2 sum up to 43. A single row is always going to sum up to 45, so we know that this is a 2. So there we got. We've filled in all the correct candidates for 29, this 29 cage, and we never even looked at any cages or their values. So what else? Where else can we find interesting shapes that stick out of your typical row, column, and box? Now, this is interesting to me. This is sticking down, and this is a pretty long line here. If we highlight these 2 boxes, we get a 92. And we know that box 1 and box 2 should add up to 90, and therefore that is a 2. And it works down here in the opposite corner as well. These 2 boxes should add up to 90, so this should be an 8. Now I'm going to diverge just a little bit. I did see that there's a 2 here and a 2 here, which forces a 2 to be here. So this is a 2-7 pair. But let's keep going. All right. So I think one of the most common of these types is when you have one cell sticking out or one cell sticking in. Suppose we were able to highlight all of these cells. We can't because they're, 1, 2, 3, 4 of them are sticking outside of the box. But we would be able to find that. But we find something a little bit similar over here, where we have two cells that are not counted in this box, or we have two cells that exceed the boundary of the box. And so we can learn some things. So first off, it should be 45, but we're getting a 53. So these two cells here are 8 more than, are 8. They must sum to 8. The total was 8 more than 45. So what are the options for 8? They happen to be limited because of what we've already got in there. And I'm going to use the calculator. I like using the calculator to demonstrate. We have a 7 here, so we cannot have a 1, 7 in this. What are we going to say? Temporary 8 cage. There's a 2 here also, and a 2 in the row, so it can't be 2, 6. So it must be 3, 5. Now, this 10 cannot have a 5, so this must be the 3 in the 3, 5 pair. And there we go. Now we've got 2 more candidates. Without doing a heck of a lot of work, we just highlighted those cells and did some math. Now, we get to fill these in because we know if we were to look here, we would see 32. So we would need a 13 in these 2 cells, which we have, to add up to 45. So just as a little belt and suspenders check. So let's do this same thing down here and see what we get. So down here in box 7, with 2 cells jumping up into box 4, we have a 55. So this is a 10. Let's go back here to our calculator. And, oh, that's right, I got rid of that. So what are the options? Well, the 9 option is out. The 2 option is out. The 2, 8 option is out. The 3, 7 option is out. But we can't have a 4, 6. Now, this 8 cannot have a 4 in it. So this is the 6 option, and this is the 4 option. So this is down here. This is the 9, and this is a 2. So we've come up with a ton of known values just by playing these games here. Okay. Let's keep moving and trying on these middle cells just to make some progress in the puzzle. I think we've really limited this 10. Can't be a 2, 8. Can't be a 3, 7. It still can be it can't be a 4, 6 because of this down here. So the only option is a 1, 9. And then this 10 only has one option because we've eliminated everything else. It must be a 4, 6. I don't see any way that we know which of the 4 or the 6. This 11, I suspect, is quite limited. The 2, the 4, the 6. So this is a 3, 8. This 13, the 8's out. And the 4 here and the 9 here, but that doesn't help us. What do we got here? Is this a better one to attack? We definitely know it's not the 2, 4, so it's the 1, 5. This 9, this 10, 2, 7, 8, 2, 7. Got the 2, got the 8, got the 3. Okay, 45. Which gets rid of that, so that's the 1, 9. And that should give us only one option here, which is 6, 7. Okay, let's fill some of these in. Okay, since there's a 7 there, it's got to be a 6. That's got to be a 7. 4, 5, 4, 6. Just 7, 1, 9. Okay. Now, if we look at these, box 2 and box 8, I think it's obvious that we have 25 here, which leaves 20 there. So I'd like to do the 20 there with the 3 and take a look at what my options are. The 6 is a 1, 2, 3. So 3 is not an option here. And the 8 and the 6 are not options because of the column. So we know this is a 4, 7, 9. And then we can just figure out here. So we've got 1, 2, 3, 4, 5. And we don't have a 6. We got a 7 here. So this must be 5, 6, 8. And that leaves us with a 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go here and look. 24, that makes this 21. What are our 21 options with 3? Well, they cannot contain a 9, so we only have 1, 6, 7, 8. And so we know that this 10 has a 2 and a 3, so it must be a 5, which makes that a 1 and that a 5. We can get rid of the 6 here and the 7 there. We can get rid of the 2 there and the 9 there. Did we come to any great new information? I don't think so. An 8 cannot be here because that would exceed its value. 6, 7. What about here? Still 4, 9. So this could be a 3, 8. And this could be a 1, 2. All right. So you can see, once again, using this idea that we don't really know what these cells are. I mean, 20, that's going to be a mess. This 14 is going to be a mess. But by knowing that a box contains 45, well, we ended up coming up with both, really limiting those down. Now there's at least one other cool shape that these cages make that push outside of a row, column, or box. In this case, it's a column. We know the column should add up to 45, but this, including the cells that stick out add up to 57, so that adds up to 12. So since there's a 3/8 here, we know that this must be a 9 or a 4. And we have a 4-9 pair there. That's kind of cool. I don't see that it does anything for us. Exactly. And over here, we got the same story. Same old story. And this one should be, since a column is 45 and we have 2 extra cells, the extra cells add up to 12. And there cannot be a 1. So that's a 9. So that's a 3. That makes that a 5. Gets rid of the 5's there. And this 9 doesn't do this. This is now 1. So now I think I've showed you all of the interesting shapes in this puzzle that have helped us. I mean, there's a good third of the puzzle that's done there. And I think moving forward, it should be, a lot easier for you to finish this puzzle. So I am going to finish the solve. I'll probably speed up the video so the video doesn't take as long. But I hope you enjoyed this, I guess, kind of a basic tutorial on the shapes, how the shapes that are formed by the cages can inform values when they stand outside or don't complete a row, column, or box, or multiples of rows, columns, and boxes. So here goes. Let's get back to the basics. Let's see, 3, 1, 3, and 7. And this is a 4, and that's a 5. So there you go. Stop the recording. Please give me a like or a subscribe. Show it to someone you love who likes Killer Sudoku. Thank you.